In a quiet stretch of runway, far from the world's biggest aerospace labs, something happened that immediately split the aviation world in two. An aircraft rolled forward. No visible fuel trucks. No refueling hoses. No jet exhaust. And yet it took off. Within hours, short clips of the flight began circulating online. Engineers paused them frame by frame. Pilots replayed them in disbelief. Comment sections exploded with one question. How is this even possible? Because for more than a century, aviation has obeyed a brutal rule. No energy input means no lift. No fuel means no flight. But this aircraft, developed in Africa, appeared to ignore that rule entirely. And that's where the real story begins. At first glance, the plane doesn't look revolutionary. It has wings, a fuselage, control surfaces that look familiar to anyone who's ever seen a light aircraft. Nothing screams science fiction. But according to its creators, what makes this aircraft different isn't what you see, it's what you don't. No conventional fuel system. No combustion engine. No batteries large enough to explain sustained flight. Instead, the team behind it claims the aircraft uses an unconventional energy architecture, one designed not to store power, but to continuously interact with its environment. That single claim is what stunned experts. Because modern aircraft are built around stored energy. Jet fuel, avgas, batteries. Every design assumes energy is consumed, depleted, and replaced. This aircraft challenges that assumption. Aviation engineers who reviewed the early footage noticed something unusual almost immediately. The aircraft's takeoff roll was shorter than expected. Its climb rate appeared steady, not aggressive, but not fading either. There were no visible signs of power drop-off. If the footage is genuine, then whatever is driving the propulsion isn't behaving like a battery or a fuel tank. That's when the skepticism turned serious. Some experts suggested hidden power sources. Others proposed off-camera assistance. A few claimed the clips were simply staged. But then longer recordings surfaced. Taxiing. Multiple passes. Extended airtime. Still no refueling. Still no visible energy swap. And that's when the conversation shifted from fake to uncomfortable. Because if even part of this claim holds up, it doesn't just disrupt aviation. It destabilizes the entire framework of how we think about energy. According to people familiar with the project, the aircraft was never meant to be a commercial jet. It was a proof of concept, a flying laboratory meant to demonstrate a principle rather than break speed records. And that principle is controversial. The idea that energy doesn't always need to be carried, that under certain conditions, it can be accessed, converted, or maintained through interaction rather than consumption. This is where many physicists draw a hard line. They argue that extraordinary claims require extraordinary evidence. And so far, no peer-reviewed paper, no independent aerospace authority, and no globally recognized lab has publicly certified the system. But here's the part that's making experts uneasy. No one has yet been able to conclusively debunk the flight itself. No definitive proof of hidden fuel. No clear explanation for the observed performance. No technical breakdown that fully accounts for what the footage shows. And, behind closed doors, some engineers admit something quietly. If this aircraft is fake, it's an extremely sophisticated one. Which raises a far more disturbing possibility. What if it isn't? Because if an aircraft can remain airborne without traditional fuel, even at a small scale, it forces a cascade of questions the industry isn't prepared to answer. What happens to jet fuel dependency? What happens to defense aviation logistics? What happens to airlines, manufacturers, and energy suppliers built around combustion? And perhaps most unsettling of all, why did this experiment emerge here, outside the usual centers of aerospace power? According to sources close to the project, the team expected skepticism. What they didn't expect was silence. No official investigation. No formal engagement. Just quiet observation. And that silence may be the loudest reaction of all. Verification in aviation is ruthless. You can't argue with lift equations, telemetry data, or certified instrumentation. Either the numbers close, or they don't. And this is exactly where the project moved next. According to insiders, the team began preparing for controlled demonstrations, not for social media, but for observers who understand what to look for. Engineers, independent technicians, people trained to spot deception. Because once an aircraft leaves the ground, there are only so many ways it can stay there. Weight must be accounted for. Thrust must be measured. Energy flow must leave a trace. And this is where the aircraft became even more controversial. Observers noted that the plane carried less onboard mass than expected. No fuel tanks. No heavy battery arrays. Yet its balance remained stable throughout the flight envelope. That alone narrowed the list of explanations dramatically. In conventional aircraft, removing fuel or batteries creates a new problem: endurance collapse. Power fades. Systems shut down. Flight time drops sharply. But during subsequent demonstrations, this aircraft didn't behave that way. It didn't surge and it didn't decay. Its performance curve looked almost flat. To some experts, that was more unsettling than explosive power would have been. Because steady output suggests regulation, not stored energy being drained, but something being maintained. That triggered a second wave of debate. Aerospace forums lit up with competing theories. Some proposed ground-based transmission. Others suggested environmental energy harvesting at scales previously considered impractical for aviation. A few argued the aircraft might be exploiting measurement blind spots rather than physics. But every theory ran into the same problem. There was no obvious external infrastructure. No visible transmission arrays. No tethering systems. No support aircraft. And yet, the aircraft kept flying. Behind the scenes, pressure began to mount, not just on the inventors, but on institutions. Because if a claim like this is false, it should be easy to dismantle publicly. And if it's true, ignoring it becomes impossible. What made matters worse was timing. The aviation industry is already under strain. Rising fuel costs, decarbonization mandates, military logistics under scrutiny, airlines desperate for efficiency gains that don't exist yet. Into that environment comes a small African project claiming a radically different approach to energy. Not better fuel. No fuel. And that's when the tone shifted again. The conversation stopped being about the aircraft. It became about precedent. Because if this system works at a small scale, scaling becomes an engineering problem, not a theoretical one. And engineering problems can be solved. Quietly, interest widened. Not public endorsements. Not press releases. Just attention. Monitoring. Requests for data that were never meant for YouTube thumbnails. The team, for their part, stayed cautious. They didn't announce commercial timelines. They didn't promise mass production. They kept repeating the same line. This is a demonstration, not a destination. But demonstrations have consequences. Because every successful minute in the air chipped away at the certainty that this couldn't exist. And every unanswered question made the silence around it heavier. The real tension now isn't whether the aircraft flew. It's what happens if someone finally forces the system into the open, under conditions where nothing can be hidden, nothing can be edited, and nothing can be explained away. Because once that happens, the world won't be debating clips anymore. And that is why the next step became the most dangerous one. Not for the aircraft, but for the idea behind it. Because the moment a system like this enters a fully controlled environment, the margin for mystery collapses. Every wire is traced. Every signal is logged. Every joule is accounted for. There is no room for interpretation, only data. According to sources familiar with the situation, discussions began about exactly that kind of test. Neutral ground. Independent observers. No creative editing. No restricted access. And suddenly, the stakes changed. For the first time, the question wasn't, is this fake? It was, who wants to find out? Because confirming the technology would do more than validate one aircraft. It would challenge assumptions that entire industries, aviation, energy, defense, are built on. And institutions rarely rush toward disruptions that make their infrastructure obsolete. That hesitation created a strange vacuum. Publicly, nothing happened. Privately, attention intensified. Engineers began modeling hypothetical systems that could explain the observed behavior, not to debunk it, but to understand what kind of breakthrough would be required if it were real. And those models led to an uncomfortable conclusion. If the aircraft is accessing energy continuously rather than consuming it, then the limitation isn't fuel capacity. It's control, which means flight duration becomes a matter of stability, not supply. That single implication is enough to unsettle anyone who understands aviation. Because endurance has always been the trade-off. Speed versus range. Payload versus fuel. Every aircraft design is a compromise. Remove fuel from the equation, and the design rules collapse. That's why some experts now describe the project not as an aircraft innovation, but as an energy experiment that happens to fly. And experiments like that don't stay isolated for long. If the principle can lift a plane, it can drive a vehicle. If it can sustain propulsion, it can power infrastructure. If it can operate without resupply, it rewrites logistics entirely. This is where speculation becomes dangerous, and why the team remains guarded. They know that proving too much, too fast, invites consequences they can't control. But proving too little invites dismissal. So they're walking a narrow line. More tests. More data. Still no final reveal. And that uncertainty is exactly why experts are stunned. Not because the aircraft flew once, but because it keeps hovering in a space where it shouldn't exist at all. Not confirmed, not debunked, not explained. Just present. And as long as it stays there, the question won't go away, and that looming moment, the demand for a definitive answer, is already reshaping behavior behind the scenes. Because once a claim reaches this level of visibility, it stops belonging to its creators. It becomes a problem that institutions feel pressured to solve. Aviation authorities don't like unknowns. Neither do defense planners, insurers, or manufacturers. An aircraft that doesn't fit existing certification categories isn't just unusual, it's disruptive. There's no checkbox for it. No framework to evaluate it. No rulebook that applies cleanly, which creates a paradox. To be certified, the system must be explained. To be explained, it must be exposed. And once exposed, it can no longer be controlled. That's why progress appears slow on the surface. But slow doesn't mean idle. According to engineers following the case, what's happening now is quiet triangulation. Small details are being compared. Flight behavior is being modeled. Assumptions are being stress-tested against the footage and the limited data that has emerged. And interestingly, the debate has narrowed. Fewer people are arguing about whether the aircraft flew. More are arguing about what kind of system would be required if it did. That shift matters, because it signals that disbelief is giving way to analysis. Some experts now suggest the real breakthrough, if there is one, may not be propulsion at all, but energy management. A way of maintaining usable power without the familiar cycle of storage, depletion, and refueling. If that's true, then the aircraft is almost incidental. It's just the most visible proof that the concept works under extreme conditions. And flight is unforgiving. If a system fails, gravity doesn't negotiate. Which is why this story refuses to die. Every day, without a clear refutation, increases pressure. Every additional test, even a small one, tightens the window of plausible explanations. And somewhere between skepticism and silence, a realization is spreading. Either this project collapses under scrutiny, or it forces a conversation the world has avoided for decades. A conversation about whether our understanding of usable energy is incomplete, not wrong, but unfinished. And if that conversation ever moves from forums and footage into formal testing, nothing about aviation will feel settled again. Because the most unsettling possibility isn't that this aircraft flew without fuel. And that unanswered question hangs over everything that follows. Because once you stop asking, where is the fuel, and start asking, how is the energy being sustained, the entire debate shifts into unfamiliar territory. One that most engineers are not trained to navigate comfortably. This is where the story becomes less about machines and more about boundaries. For decades, aerospace innovation has been incremental. Better materials, smarter avionics, slightly more efficient engines. Breakthroughs happen, but they happen inside accepted frameworks. Everyone agrees on the rules first, then competes within them. This aircraft doesn't do that. It appears to operate outside the usual framework, which is why it's being treated with caution rather than celebration. Some experts privately admit that the most unsettling aspect isn't the technology itself, but the location of its origin. Not because of capability, but because breakthroughs are expected to come from certain places. Major labs, defense contractors, billion-dollar research programs. When something radical emerges from outside that ecosystem, the first instinct isn't curiosity. It's resistance. And that resistance shows up in subtle ways. Delayed responses, vague statements, a reluctance to formally engage. Not denial, just distance. Yet the aircraft remains. It hasn't been quietly dismantled. It hasn't disappeared. It hasn't been publicly discredited. It exists in a strange limbo, visible enough to provoke debate, opaque enough to avoid conclusion. And that limbo is becoming increasingly uncomfortable, because the longer it persists, the harder it becomes to dismiss without looking negligent, and the harder it becomes to confirm without opening doors that can't be closed again. This is why some analysts believe the next chapter won't be written by the inventors at all. It will be written by whoever forces the issue. A university demanding open testing. An aviation authority requiring formal explanation. A rival researcher attempting replication. Any one of those would collapse the uncertainty, in one direction or the other. Until then, the aircraft continues to serve as a mirror. To skeptics, it reflects the dangers of misinformation. To supporters, it reflects the limits of institutional imagination. To experts, it reflects a problem they can't easily solve. And that is why this story refuses to settle. Because it's no longer just asking whether an African aircraft flew without fuel. It's asking whether the way we decide what's possible is shaped by evidence or by expectation. And that's where this story must pause. Not because it's finished, but because the answer hasn't landed yet. Right now, the aircraft exists in a narrow space between belief and disbelief. Between footage and proof. Between what has been shown and what has been fully explained. History is full of moments like this. Ideas that sounded impossible until they weren't. And ideas that collapsed the moment real scrutiny arrived. The difference was never hype, it was verification. So, this isn't a verdict. It's a waiting room. If independent testing confirms the claims, this aircraft will be remembered as the moment aviation quietly crossed a line it never planned to. And if the claims fall apart, it will stand as a warning about how easily hope can outrun evidence. Either way, something important has already happened. A conversation has been forced open. Assumptions have been challenged. And experts, real experts, are paying attention. Because whether this aircraft changes aviation or simply exposes our hunger for breakthroughs,